Welcome students in the third video of work, power and energy. In this video, I will explain about mechanical energy and its form. So let us start mechanical energy. The energy possessed by a body due to its state of rest or of motion is called mechanical energy. So we can write mechanical energy is of mechanical energy is in two forms. The first one is known as potential energy and second one is known as kinetic energy. So first one potential energy and second one is known as kinetic energy. We can also say mechanical energy is the sum of potential energy and kinetic energy. That is, total mechanical energy is equals to potential energy plus kinetic energy. Now, let us see potential energy. The energy possessed by a body by virtue of its position or configuration is known as potential energy. This potential energy is of, in mechanics, the potential energy is of two types. The first one is known as gravitational potential energy and second one is known as elastic potential energy. So, gravitational potential energy and elastic potential energy. Elastic potential energy. So these are the two types of potential energy. Now let us find the expression for gravitational potential energy, and first let us see what is gravitational potential energy. The energy possessed by a body by virtue of its position above the surface of earth is known as gravitational potential energy. Let us find the expression for gravitational potential energy. Expression for gravitational potential energy. For this, let us consider the surface of Earth and a body of mass small m. A body of mass small m on the surface of Earth. We will take it to a height h. The work done in raising the body to a height h is stored as the potential energy of the body. So we can find potential energy is equals to work done in raising the body to a height h. Now we know that work done is equals to force into displacement. To raise the body, we have to apply some force, and that force must be at least equals to the force of gravity, that is mg, and height we have taken to h. That's why potential energy is equals to mgh. So this is the expression for gravitational potential energy. Next one, I said elastic potential energy. So what is elastic potential energy? The energy possessed by a body by virtue of its configuration, means shape and size, like the energy stored in a stretched rubber band. We are doing some work in stretching the rubber band. That work done is stored as the energy in that rubber band. Similarly, more examples we can say about elastic potential energy. Energy is stored in a compressed or a stressed spring. Now, this is all about gravitational and elastic potential energy. So, we have just studied about potential energy. Let us learn the next form of mechanical energy, that is kinetic energy. So, what is kinetic energy? The energy possessed by a body by virtue of its motion is called kinetic energy. Now, or we can say that it is the energy possessed by a body by virtue of its motion. So, we will also find an expression for kinetic energy. So, next one we are finding the expression for kinetic energy. Kinetic energy. For this we will consider, let m a mass of a body, which is initially at rest. That is, initially rest means we can say that u equals to 0. Suppose this is the surface, and in this surface a body of mass m is kept. Now we will also consider, suppose a force F is acting on the body, and this force displaces the body through a displacement S, and the body acquires a velocity v. As I said, initially at rest u equals to 0. After displacement S, suppose it acquires a velocity v. The applied force also produces an acceleration a in the direction of applied force. So we can write as F equals to a force applied on the body. A is equals to acceleration produced in the direction of applied force, and v is equals to velocity acquired. Now the body is moving, so we will find the kinetic energy. Kinetic energy is here also, it will be the work done in acquiring the velocity from 0 to v. As we know, work done is equals to force into displacement. Force is equals to mass into acceleration into displacement. As we know from the equation of motion, v square is equals to u square plus 2as. V is the final velocity, u initial velocity, plus 2 acceleration produced a, s is the displacement. So we can find v square is equals to 2as, or a is equals to v square by 2s. So this is the acceleration. If we will put this value of acceleration, then we will get mass into v square by 2s into s. This will get cancelled, and we get kinetic energy is equals to 1 by 2 mv square. So we can see kinetic energy depends upon the mass of the body and the square of velocity. So if mass will be doubled, kinetic energy will be also doubled, and if velocity will be doubled, kinetic energy increases by 4 times. That means 2, it will become 4. Now, so we can see this is the expression for kinetic energy. Next we will see one more term related to this, that is relation between kinetic energy and linear momentum. So we will see relation between kinetic energy E and linear momentum P. So let us start this point. Let us consider M, mass of the body, M, mass of a body, and V, velocity of the body. Then we can write kinetic energy E is equals to 1 by 2 mv square, as we just studied. And also we are knowing linear momentum P is equals to mass into velocity. From here, if we will find the value of V is equals to P by M. Now put this value in equation 1. We can write, putting the value of V in equation 1. We will get kinetic energy E is equals to 1 by 2 mass into P square by M square. This will get cancelled and we will get E is equals to P square by 2M. So this is relation between kinetic energy and linear momentum. We can also find P square is equals to 2me, or we can write P is equals to root under 2me, square root 2me. So this is the another relation between kinetic energy and linear momentum. In next video, I will explain about work energy theorem. Thank you, students. Thank you so much.